3I Atlas, an enormous glowing object the size of Manhattan, is speeding toward Earth on what appears to be a planned, coordinated trajectory. It's going so fast that you could fly from New York to Los Angeles in just 1 minute.
Some discoveries challenge our understanding of the universe, but a few tear through everything we thought was possible. The James Webb Space Telescope, famed for its perfect clarity, has caught sight of an interstellar object so precise, so unnatural in its movement, that experts tried to keep it quiet. But secrets like this don't stay buried for long. Stay with us to the end, because this secret is just coming to light. The leak that broke the internet. Something was never meant to be seen. A single infrared image leaked from a closed research channel on the 6th of August, 2025. Within hours, it spread like wildfire across the internet, leaving scientists scrambling to explain what the James Webb Space Telescope had just captured. This wasn't a star, a planet, or even a normal comet. It was 3I Atlas, an interstellar visitor that seemed to defy every law of motion and light we understood. The image came from Webb's near-infrared spectrograph during a quiet observation session led by astrochemist Dr. Martin Cordner. The goal was simple: determine what this object was made of. What the team found instead reshaped the conversation entirely. The comet's coma, the gas and dust cloud surrounding its core, showed a strange, uneven structure, like something was venting in bursts rather than evaporating naturally. Carbon monoxide and carbon dioxide were escaping faster than water vapor, hinting at engine-like outgassing rather than simple solar heating. Then came the visual anomaly, a thin, needle-like beam of light emerging from the comet's sun-facing side. It wasn't a reflection or flare. It was narrow, focused, and steady, cutting through the darkness with precision. What made it even stranger was its direction. While most comet tails stretch away from the sun, this one seemed to push forward, as if fighting against the light, rather than fleeing it. Scientists at the European Southern Observatory privately called the structure mechanical. The nucleus appeared small, between 440 meters and 5.6 kilometers across, but unnervingly geometric. Hexagonal symmetry traced the surface like it had been shaped, not formed by accident. By late August, NASA tried to contain the spread, but the leak was already everywhere. Nearly 70 research papers appeared in less than 2 months, all racing to explain how a body that shouldn't exist moved, breathed, and shone the way it did. Was it a natural traveler from a distant system, or a designed probe, built by something that had already been here before? Whatever the truth, Webb's image wasn't just data. It was a message. And the deeper scientists looked, the more it seemed like someone, or something, was looking right back. And yet, what started as one leaked image quickly became impossible to ignore. Because when one telescope sees something strange, it's an anomaly. But when every major eye in space starts turning toward the same object, it's no longer a mistake. It's a summons. Eyes across the heavens. If one telescope sees something strange, it's worth a second look. But when every major eye in space turns to the same object, something bigger is at play. That's exactly what happened with 3I Atlas. Since its discovery, it hasn't just drawn attention. It's forced the world's most powerful observatories to stop what they were doing and look closer. NASA's Hubble Space Telescope, one of the most in-demand instruments in orbit, is notoriously hard to book. Scientists submit requests months in advance for just a few minutes of its time. But for 3I Atlas, the rules changed. Hubble keeps a small window open for what NASA calls targets of opportunity, objects that appear suddenly and won't wait around. 3I Atlas qualified, earning a rare pass to the front of the line. On the 21st of July, when it was about 446 million kilometers from Earth, Hubble locked on. the image it returned was haunting. The comet's icy nucleus left a long, faint trail, while the stars behind it stretched into streaks, revealing how fast it was moving. From these frames, scientists estimated its nucleus to be between 440 meters and 5.6 kilometers across, far smaller than first thought. Early size guesses had been inflated because its brightness came not just from its core, but from the vast cloud of dust surrounding it. Now, with sharper resolution, the view was clearer and more unsettling. But Hubble wasn't alone. Another NASA mission, the Transiting Exoplanet Survey Satellite, TESS, also caught the visitor in its sights. Designed to search for planets around distant stars, TESS uses 4 wide-field cameras to scan nearly the entire sky. Yet tucked inside its data were images of 3I Atlas that no one expected. Long before its official discovery, TESS had already seen it between the 7th of May and the 2nd of June, 2025. When researchers reanalyzed those early frames, the comet's brightness measurements matched what later telescopes found. But something didn't add up. Its light curve behaved oddly, hinting that this object wasn't reflecting sunlight like a typical comet. As the analysis deepened, one thing became clear. What TESS and Hubble had captured wasn't just a frozen rock passing by, it was the beginning of a puzzle that might change what we think moves between the stars. But light alone can only tell part of the story. To truly understand what they were seeing, scientists needed to know what shape they were dealing with. And that's when the familiar turned deeply unnatural. What they found next defied every known pattern of how comets spin, shine, or even exist. A shape that shouldn't exist. If something looks ordinary but refuses to behave that way, it's usually hiding something. That's the strange truth scientists ran into when they tried to pin down the shape of 3I Atlas. After the space telescopes captured its light, the next logical step was simple: measure how that light changes as the comet spins. But what they found was anything but simple. Adina Feinstein and her colleagues at the University of Chicago used data from NASA's TESS satellite to extract a light curve, the graph that reveals how an object's brightness rises and falls as it rotates. A clear pattern would mean a predictable spin. But 3I Atlas didn't play by the rules. Its light stayed almost too steady, too even, as if it was reflecting sunlight from all directions at once. The team did find faint traces of 2 possible rotation periods, one around 29 hours and another near 16 hours, but the data was messy. TESS, built to detect large planetary transits, might not have been sensitive enough to read such fine details from a small, distant target. Even so, that strange steadiness stood out. Unlike Oumuamua, whose brightness shifted wildly as it tumbled through space, 3I Atlas gave off a smooth, almost controlled signature. To confirm it, astronomers on Earth joined the chase. Ground-based observatories specializing in comet tracking focused their instruments on the object and found something familiar, the same 16-hour spin period TESS had hinted at. That agreement gave scientists a little more confidence, but it also deepened the mystery. A rotating body that reflects light this evenly usually isn't rough or jagged like most comets. It's usually symmetrical and balanced, and that's what unsettles researchers the most. Because in space, nature rarely builds symmetry like this, certainly not in something that's been drifting through interstellar chaos for eons. The more precisely they studied it, the more it looked engineered, or at least sculpted by forces we don't yet understand. But that's just what space telescopes have revealed. Back on Earth, new instruments would soon take the mystery further. And what they found made the idea of natural even harder to defend. Before we dive into what made scientists question the laws of motion, take a second to hit that like button if this story already has you on edge, because what comes next will challenge everything we know about how the universe works. A tale that's turning physics upside down. Normally, Every comet streams away from the sun, pushed by radiation and solar wind. But when astronomers locked their sights on 3I Atlas, that rule shattered. Its tail wasn't fleeing from the sun. It was turning toward it, bending physics itself as if something inside was pushing back. What they saw next didn't just challenge science, it terrified it. What looked like an ordinary interstellar object began behaving in a way no natural body ever has. And it's forcing scientists to question whether nature is really behind the wheel this time. The first hint came from the James Webb Telescope's infrared sweep on the 6th of August, 2025. Its instruments detected dust and gas streaming upstream against the flow of sunlight, as if something beneath the comet's surface was propelling it forward. Data showed bursts of carbon monoxide and carbon dioxide erupting in rhythmic intervals, launching dust grains that broke apart mid-flight and reflected even more light. It looked patterned, mechanical, and strikingly deliberate. By the end of August, the Gemini South telescope in Chile confirmed what Webb had caught. Using its multi-object spectrograph, scientists mapped a tail that stretched roughly 1/120th of a degree across the sky, triple the size seen just weeks earlier in July. The increase in brightness and activity meant one thing. 3I Atlas was heating up fast as it raced toward its October 30th perihelion, and something deep within was driving that acceleration. Meanwhile, light curve readings from NASA's TESS observatory told a different kind of story. Instead of a cluttered spin or jagged reflection pattern, the comet's surface returned smooth, consistent light, two even for a chunk of rock battered by eons of travel. To the teams studying it, that meant it wasn't just turning, it was controlling its spin. Add to that the Swift Observatory's ultraviolet data, which caught massive water outflows, around 40 kilograms per second, and the picture becomes even harder to explain. 3I Atlas wasn't a dead relic drifting through the void. It was active, focused, with its tail moving like an engine plume instead of a natural trail. But even as telescopes tracked that impossible tail, something else began to emerge. A pattern in its path, one far too deliberate to be a coincidence. It wasn't just moving, it was navigating. And the route it traced through our solar system looked eerily familiar. A path too perfect to be chance. Every object in the cosmos follows the same rule. Gravity decides where it goes. Planets orbit stars, comets fall toward light, and nothing chooses its own path. But then came 3I Atlas, and that order broke. It isn't moving like a drifting relic from deep space. It's following a route that feels calculated, threading our solar system with the precision of a planned mission. Instead of tumbling in from the outer dark like a lost wanderer, 3I Atlas entered from above the ecliptic plane, slicing past Mars just days ago, and now steering toward Venus. From there, it's on track to loop around Jupiter, using the planet's gravity like stepping stones, gaining speed at every turn. It's the same slingshot technique NASA uses to save fuel on interplanetary missions, except this object is doing it on its own. On October 8th, it swept within about 0.7 astronomical units of Mars, close enough for orbiters like ExoMars Trace Gas Orbiter and Mars Express to catch it venting massive plumes of water vapor, more than any interstellar object astronomers have ever tracked before. Scientists say that kind of water content hints it may have formed around a distant sun, possibly in an exoplanet system rich in liquid oceans. But what really turned heads is that it isn't slowing down. Every pass, every turn seems too efficient. It doesn't drag, just acceleration. Harvard astrophysicist Avi Loeb ran simulations and found the odds of this exact trajectory happening by random chance were less than 1 in a billion. He noted how perfectly the object's path mirrors the gravity assist chains used by robotic spacecraft. Even with Hubble's revised measurements putting its size closer to 5.6 kilometers, the movement still looks engineered. Skeptics, like Dr. Ehsanul Haque in Malaysia, argue the orbit can still be explained by natural forces, but even they admit the pattern is uncanny. The comet's timing is also suspiciously precise. It will swing behind the Sun on October 30th, slipping into a perfect blind zone just as Earth-based telescopes lose sight, before re-emerging in December when SOHO, S-P-H-E-R-E-X, and MAVEN can pick it up again. This is too perfect to dismiss as a coincidence or to be referred to as random. The deeper scientists looked, the more that path began to whisper intent. But when they turned their focus to the comet's chemistry, the message became clearer. Before we go further, share this with someone who follows space news, because what's hiding in this comet's glow might be the first clue that we're not alone. The signal in the cyanide glow. Something strange began showing up in the data. A chemical signature no one expected to find this strong and this soon. When astronomers analyzed the August observations of 3I Atlas, one signal cut through the noise: cyanide. Bin Yang, an assistant professor at Diego Portales University, was the first to identify the cyanide band emission, proving that the comet was releasing hydrogen cyanide as sunlight vaporized its icy surface. It's a common process among comets, but what made this one unsettling was how clear and concentrated it appeared, while the comet was still more than 2.5 astronomical units from the Sun. Follow-up readings from other observatories confirmed the detection. The CN signature wasn't fading, it was growing stronger. By early September, a new paper revealed that 3I Atlas was spewing around 800 sextillion cyanide molecules every second. That's low for a typical solar system comet, yet its composition made it stand out even more. When scientists compared the ratio of dicarbon to cyanide, they found an unusually small value, less than 0.09, classifying the comet as severely carbon chain depleted. That might sound technical, but the meaning is simple. It didn't form in the kind of rich, carbon-heavy nursery that built our solar system. It came from somewhere leaner, colder, and far less forgiving. Interestingly, the interstellar comet Borisov shared the same trait, hinting that these visitors might come from a similar kind of star system, one with very different chemistry. Still, with only 2 examples to study, scientists are cautious. What happens next could rewrite those early assumptions. As the comet races closer to the Sun, it could begin releasing far more gas and water vapor, or it could fracture completely. Comet expert Karen Meach describes these objects as fragile, dirty snowballs, and if 3I Atlas breaks apart, the burst of fresh ice could trigger another wave of emissions that reveal even more about its strange makeup. As the chemical patterns grew stronger, so did the questions. But the loudest response didn't come from the scientists. It came from the silence above them. The bizarre quiet from the watchdogs. Silence isn't just golden. Sometimes it's the loudest alarm you never hear, especially when it's hanging over the United States Space Command, NORAD, and the European Space Agency. This interstellar object, named 3I Atlas, the fastest interstellar visitor ever clocked at more than 130,000 miles per hour, should have been front-page news. Instead, the institutions built to monitor cosmic threats have gone completely quiet. There have been no briefings or statements, not even a routine all clear. Just a deliberate quiet that feels less like calm and more like the calm before something breaks. By early September, nearly 70 research papers had flooded the scientific community. Every major observatory, from ground to orbit, was tracking it. Yet while data poured in, the military's channels stayed frozen. Leaked notes from the All-Domain Anomaly Resolution Office, ARROW, hinted that the silence wasn't neglect, but design. According to insiders, top-level simulations were running non-stop, rehearsing what would happen if this interstellar object suddenly changed trajectory or began transmitting a signal. What if it wasn't a comet, but reconnaissance, something mapping us from within our own solar system? Scientists and defense analysts are divided. Some think it's an automated probe, the kind of self-guided surveyor humanity dreams of building. Others believe it's a test of how we respond when the unknown knocks on our doorstep. Behind sealed bunker doors, meetings are said to be focused not just on what 3I Atlas is, but on how to react if it calls back. Do we respond, stay silent, or prepare for something we can't intercept? Then came the chemistry, the kind that deepened the unease. In August, Gemini Observatory's spectrograph caught a faint cyan glow. Hydrogen cyanide breaking free from water ice. Billions of molecules every second. It's weak for a local comet, but strange for something from another star system. Its carbon ratio, far lower than anything native, suggests it was born in a region poor in heavy elements, a cold, ancient nursery long beyond our reach. That discovery should have brought answers. Instead, it made the silence feel heavier. Because if the readings are right, this thing didn't just come from afar. It came from a place where life, as we know it, may never have had a chance to begin. When institutions meant to protect us refuse to speak, others start to. And among them, one voice dared to say what everyone else wouldn't dare. Is 3I Atlas an alien technology? For weeks, the data on 3I Atlas seemed strange but explainable, until one scientist suggested something far more unsettling. What if this wasn't a comet at all, but technology? That idea came from Avi Loeb, a Harvard astrophysicist known for pushing boundaries in cosmic debate. His name has become almost synonymous with controversy. And whenever something from deep space defies easy explanation, Loeb's theories usually follow close behind. In July, soon after the discovery of 3I Atlas, Loeb published a paper noting that the object appeared too large to be a typical interstellar asteroid. Early size estimates suggested a radius of about 10 kilometers, far heavier than any known interstellar object. Given how little material exists between stars, he argued that something this massive crossing into our solar system should be almost impossible. To Loeb, that rarity demanded a deeper look. If 3I Atlas wasn't what it seemed, could it be something built, something sent? Days later, he doubled down with a new paper co-authored with two collaborators from interstellar research nonprofits. The title left little to interpretation. Is the interstellar object 3I Atlas alien technology? This time, Loeb went further, analyzing the comet's motion to see if it could be under intelligent control or even designed for reconnaissance. He referenced the dark forest theory, a chilling answer to the Fermi paradox, suggesting that advanced civilizations might stay silent out of fear or strike first to survive. What if, he wondered, 3I Atlas wasn't just passing through, but soon cracks appeared in his case. When Hubble's August observations refined the comet's size to roughly 5.6 kilometers across, Loeb still based his arguments on the outdated 10-kilometer estimate. Critics, including geoscientist A.K.M. Ehsanul Haque, quickly pointed out that the object's flight path and slight deviations were fully consistent with natural dynamics, not artificial maneuvers. For now, most scientists view Loeb's claims as speculation built on uncertain data. Still, his question lingers in the background of every new observation. What if this pattern isn't a coincidence? Because as the comet moves deeper into the solar system, new data are beginning to challenge even the skeptics, suggesting that whatever 3I Atlas is, it may not behave like anything nature has made before. Theories split, data collided, and fear took root. But no debate, no simulation could change one truth. Whatever this thing is, it's heading straight for the sun. And what happens there will either end the mystery or confirm our worst suspicion. The sun test: what happens when 3I Atlas gets too close. As 3I Atlas races toward the sun, scientists are bracing for what could be its final and most revealing test. Whatever this object truly is, natural or not, the heat and gravity it's about to face will expose its secrets. On the 30th of October, 2025, the comet will reach its closest point to the sun. It's perihelion, about 1.4 astronomical units away. That's roughly the same distance between the sun and Mars. At that point, it will vanish from our view, swallowed by the sun's glare. For now, no telescope on Earth will be able to track it directly. But this disappearance isn't the end. It's the calm before something critical. As it swings behind the sun, several missions are already lined up to catch any sign of change. NASA's SOHO and MAVEN spacecraft, along with SPHEREX, Hubble, James Webb, and the Gemini Observatory, will be watching for shifts in brightness, heat, or movement that could reveal what 3I Atlas is really made of. The challenge is simple but unnerving. How will it behave under the sun's intense radiation? If the object breaks apart, it would suggest fragile ice and dust, consistent with a comet. But if it survives the encounter or changes course, it could rewrite what we think we know about interstellar visitors. Every observation made now feeds into one pressing question. What kind of journey could have brought this object here? Its path through the stars, its spin, even the gases it releases, all may hint at an origin we haven't yet traced. Astronomers are racing against time. Once 3I Atlas slips behind the sun, we'll have to wait until early December to see it again. By then, it could look completely different. Whatever happens at perihelion, this moment is critical. If 3I Atlas emerges intact, brighter, or moving unpredictably, it may force scientists to revisit the most unsettling idea of all, that something out there may have sent it, because things that endure the sun's wrath aren't made to explore. They're made to observe. So, what do you think? Is this just an ancient wanderer or a watchful machine sent to study us from within our own solar system? Share your thoughts with us in the comments section below. And subscribe for more deep space mysteries just like this one, because the next signal we detect might not be from a star, but from whatever sent 3I Atlas in the first place. Thanks for watching. See you in the next one.